this video, I'm going to explain how to solve multiple choice questions in magnetism. In this problem, three wires of equal length are bent in the form of a circle, semicircle, square. Length of the wire is same in the three cases. Then in question is to find out which will experience maximum torque. Four options given: circle, square, semicircle, all of them. Torque is given by this expression. Torque experienced by a loop in a magnetic field is given by this relation. Torque is I A B sine theta, where I is the current flowing through the coil, A is the area of the coil, B magnetic field, and theta is the angle between the normal to the coil and the direction of the current. For a given perimeter, circle has got largest area. So this area is large, even though length is or perimeter is same, circle will have largest area. For a given perimeter, circle will have largest area. So the circle will experience maximum torque. So the correct option is A. In this problem, two identical coils of radius R are kept at a distance R, and current is flowing in the same direction, both the coils. We have to find the magnetic field at a point which is exactly at R by 2. Distance between the center of the coil is R. This distance is R. We have to find the magnetic field at a point which is at a distance R by 2. This point is P. We have to find the magnetic field at a point P which is at a distance R by 2. These are the four options. You know the magnetic field at a point on the axis of a coil is given by this relation, where N is the number of turns in the coil, I the current, R radius of the coil, X is the distance of the point from the center of the coil. Now we have to find the magnetic field at this point. Now two coils are there, so we can use a right hand thumb rule to get the direction of the magnetic field. Here current is in the same direction, so the right hand thumb rule is curl the fingers of your right hand in the direction of the current. Then the thumb will give you the direction of the magnetic field. See, here current is in this direction, curl the fingers in the direction of the current, then thumb is giving the direction of the magnetic field. See, thumb is this side. Here, since the current is in the same direction, magnetic field because of this also in the same direction. So we have to add magnetic field here because of this coil. B is equal to mu 0 n number of turns, I current, R square 2, R square plus X square all raised to 3 by 2. For this X we have to put R by 2 because this point is at a distance R by 2 from the center. So instead of this X we have to put R by 2. So this is the magnetic field here because of this coil. Magnetic field here because of this coil also will be same. So here, since current is in the same direction, because of this coil, field is this side, because of this also this side. So we have to add. So it will be double of this. So we have to double it. This is the field here because of this coil. Because of this coil also will be of the same magnitude, and its direction is in the same direction, so it is we have to multiply by 2. Then 2 will get cancelled. Now mu 0 ni R square 2 square, when you square this 2 square is 4, then 4r square plus r square, it is 5r square, then this 2 square is 4, then that is all raised to 3 by 2. Take this power inside, so it is 5 raised to 3 by 2, then this 2 will get cancelled, so it is r cube, then 4 raised to 3 by 2. The 4 raised to 1 by 2 is 2, square root of 4 is 2, then 2 cube is 8. Take this 8 to the numerator, then r square, r cube, so it will be r after the cancellation. So magnetic field here, because of these two coils, we have to add field here because of this and field here because of this. Since both are in the same direction, we have to add. Finally we will arrive at this answer. So the correct option is this B, 8 and mu 0 I 5 raised to 3 by 2 R. This is the correct option. In this problem, a wire of length L carries a current I along the Y direction. So along the Y axis there is a wire and it carries a current I, and there is a magnetic field, and it is given in the component form beta by root 3 I plus I cap plus j cap plus k cap Tesla. You have to find the magnitude of Lorentz force. So to solve this problem, you should have the fundamental idea of vector product of two vectors. Magnetic Lorentz force is given by IL vector cross B vector. Since current is along the y-axis, IL vector can be written as IL j cap. Unit vectors along the x-axis, y-axis and z-axis are respectively I cap, j cap, k cap. Now IL vector can be written as IL j cap. Magnetic field is given, that is beta divided by square root of 3 I vector plus j vector plus k vector. So we have to find the cross product of these two vectors. Now you know I cross j is k, j cross k is I, then k cross I is j. Vector product is not commutative. I cross j is k, j cross I will be minus k. Now here you can see j cross I. IL beta divided by root 3, then j cross I. J cross I is minus k. I cross j is k, here it is j cross I, so it's a minus k. Then j cross j is 0. You know I cross I is 0. Then cross product of two equal vectors will be 0. J cross j also will be 0. K cross k also will be 0. So now you see here j cross j, it is 0. Next to this, with this IL beta by square root of 3 j cross k. J cross k is I. Then you have to find the magnitude. If r vector is xi plus yj plus zk, its magnitude is given by square root of x square plus y square plus z square. So here you have to find the magnitude of Lorentz force. So here magnitude of the Lorentz force is given by the square root of x square, because this is the component along the x-axis. So x square plus plus the square of this. This is the component along the z-axis. There is no component along the y-axis because there is no j cap. So square root of x square plus y square plus z square. So this square plus square of this. Now when you square this, I square L square beta square divided by 3 square root Root of 3 square is 3. So when you square it, it will become positive. Then similarly here also, I square plus I square L square beta square divided by root 3 square is 3. So it will be 2 times I square L square beta square by 3. Then square root of 2 by 3 I square L square beta square, when it is taken outside, I beta L.